Hello guys, welcome back to my channel, Techie Boy. So today I will be talking about compressor simulation tuning. This is the next step of the next episode for the compressor rating simulation. So here I have two kinds or two modes of compressor simulation. The first one is the simulation mode and the second one is rating mode. I have explained these two modes previously, but as a review, simulation mode is where we only specify the pressure ratio or the pressure uh, of the outlet stream, while in rating mode we need to supply the compressor curve. So we have the dependencies between the flow that coming into the compressor to the head delivered by the compressor and also the efficiency of the compressor. In a simple way, simulation mode is more simple than the rating mode. So now in this video I will be focusing on the tuning of compressor. So in order to know how to tune, we need to know the effect of each input variables. So we know what to do if our simulation doesn't match the plant data. So first I will go to the simulation mode, where this is the preliminary simulation. Usually we'll use this simulation mode. So I have three variables to be observed. The first one is the outlet pressure, then the power of the compressor, and the outlet temperature. Okay, so the first thing is I would like to change the flow rate. You could see that the pressure of the outlet still is the same. Yeah, nothing changes. Yeah, the temperature stays the same. However, the power increase. Yeah, this is makes sense. Yeah, because we have more power. Okay, because we have more flow, we need more power. Okay. The next thing is if I change the pressure, yeah, will have no change here in the outlet pressure because we specified the outlet pressure as specified variables. Yeah, I lock this variable. Okay, so nothing will change, but the power, of course, because the delta P is greater, it will have a larger power. Yeah. And it also will affect the temperature. Okay. The next thing is about the temperature. If I decrease, of course, the temperature of the outlet, sorry, if I increase maybe because this is at the saturated liquid. Okay, if I increase, it will also increase the temperature of the outlet. Okay, and it also affect the pressure, sorry, the power. Yeah, you see that the value is changing. Okay. Okay, so this is the simulation mode. Yeah, if we look at this way, actually simulation mode is not really representative if we have more rigorous simulation, yeah, because the change of variable is not that much and not that clinical, not that uh, not that powerful. Yeah, so we will go to the rating mode now. The basic one is I already showed you before. If I change the flow now, it will affect the power, pressure, and also temperature. Okay, we'll view the plot curve. Yeah, make it bigger. See if I increase the flow. Oh, sorry, too much. It will move to the right side of the curve, so it will have less head. Yeah, you see the pressure will decrease here if I increase the flow. Okay, and then it will also affect the temperature because we have a different efficiency. Now, if I plot the efficiency tab, yeah, you see that we have a lower efficiency at higher flow at this case. Okay, but if we have the operating flow is at here, yeah, around this point 300 to 1000, we have an increase of efficiency if we increase the flow. Okay, I will change back. The next thing is, what is the effect of pressure and temperature of the inlet to the curve? Let's see. First, if I increase the temperature, you could see that the curve is getting to the right side. Why? Because when I increase the temperature, it also affects the actual volume flow. So here, if you see the x-axis, it is the actual volume flow. So if I go to the properties, you see here, 1183. If I have 161, 1154. So it is lower at lower temperature. Okay, so if we have higher in the temperature, it will also affect that it will decrease the flow. It goes the same as the pressure, so this pressure also will affect the actual volume flow. So here is 1154. If I increase the pressure, it will become 952.7. So it will decrease the actual gas volume flow. So we will have a bigger head. Okay. Let's change back. Oh, one more thing that I forget actually, in this rating mode, yeah, we cannot specify the polytropic efficiency, right? But in simulation mode, we have a chance for that. But how it will affect? Yeah, of course, it will affect the temperature. So if I have only 70% of efficiency, you could see that temperature is larger. The temperature rise. But if I get higher temperature, I will have more low temperature. Okay, this is also one of the way to tune this compressor at the simulation mode. If you experience that the pressure, the temperature outlet of the compressor is not matched with the plant data, so you can tune from this efficiency also as one of the choice. Okay, and the very important one actually is about how if we already put the right flow, right conditions, but we have wrong head at the rating mode. Yeah. So for example, at this condition, usually the pressure is not 600 kPa. It is usually lower. So this is a very normal one for the operating compressor that probably already quite old, so the performance have deteriorated. So it is a very common situation. So what you do is you can decrease the head here. So for example, I will decrease the head by 100. So okay, and I will implement it to the curve. Okay. And you will see that pressure is decreasing. It become 556. So this way, actually, you can do a performance check because you see that the usually with this amount of flow, the compressor could deliver uh, 600 kPa, but now because of the performance deterioration, uh, the head is lower. So you could know what is the actual efficiency of the current compressor. You could know what is the performance of the compressor. So you have the evaluation for that unit. Okay, so that's my tips and trick to tune the compressor. So I hope that you could apply these tricks to your simulation. Okay, see you at the next episode. Bye bye.